All right, recording has started. All right, so this is the first day of Unit 2. 2.02, Day 1, measure angles. So we're going to convert the angle measures between degrees and radians. That sounds fun. And we're also going to convert the angle measures between degree minutes and degree decimals. That's going to be something new. Goal 1, you may have done that in your past geometry class. Maybe. I doubt you've done the second goal. Well, today's lesson, I think, is relatively easy. I would say this is probably the easiest lesson of this unit. All right, let's go ahead and start off. Parts of the angle. So here we have the angle between two rays. This is the angle, of course. This is the initial side, and then this would be the terminal side here. All right, the vertex. This is the point here, the vertex. So it could be a coordinate. All right, think of it this way. The starting that does, I'm sorry, let me start over. So our starting ray would be the initial side. So the one ray that rotates away from the initial position, that is called the terminal ray or terminal side. So we start here, we rotate away, that is the terminal side, and it creates an angle between the two. Pretty basic. All right, limits of angle measures. All right, so up until now, we have dealt with angles from 0 to 360 degrees. However, it can go a lot further. So we can have multiple rotations around the axis here. It can rotate counterclockwise 3 times. So that degree will get larger than 360. Oh boy. All right. Clockwise rotations are negative degrees. So negative angles move clockwise. Positive degrees, positive angles move counterclockwise. One way to think about it is in the Olympics, track and field, which direction do they run around the track? Yeah, they run counterclockwise. That is the proper way. So running counterclockwise is positive angles. All right, sorry, I was reading chat. I thought there was a question. Is there a problem with Neuro for some people right now?
So what's going on is that, when you move to the next page, her pointer is going to get fixed. It's because you probably went to full screen or changed the screen, the dimensions of it, and that makes the pointer go like separated.
Oh, I see. Does it fix it if I kind of go back, then go forward again? Is
That
that
should fix it, yeah.
okay? Okay, yeah, that's Neuro. It's not really computer; it's Neuro. All right. So radians. You've probably dealt with this before, but we can do calculations in degree mode or in radian mode. So a full rotation is 360 degrees. I think we all know that. In radians, a full rotation is 2 pi. So we can talk about problems in degrees or radians. I would say for the majority of this class, we'll be doing stuff in radians, probably starting middle of next week is my guess. Most stuff is done in radians. So again, full rotation is 360 degrees. In radians, that's 2 pi. So what's a half a rotation? How many degrees? 180 degrees. And how many radians is that? Just pi. Yep. So half a rotation is 180 degrees. In radians, a half rotation is just pi. What's a quarter? How many degrees would be a quarter rotation? So from this point up to here. How many degrees is that? 90 degrees. And the radians? Pi over 2. Yep. On this page here, I have those basic degrees and radians showing. 0 degrees, 90 degrees, 180, 270, back to 360. Radians, 0 radians, pi over 2 radians, pi radians, 3 pi over 2, and then 2 pi. Something to note, if a problem ever has pi in it, when talking about like when we start doing cosine sine, kind of get ahead of myself here. Whenever you see pi, it is a given they're talking about radians. You'll never have like a pi degrees. You'll never mix and match pi with degrees. Keep that in mind. We actually will have a super complex one next week. Can't wait. All right, conversion factors. So if we want to convert from radians to degrees, the conversion is 180 divided by pi times the radians. So this is the Greek symbol theta. This generally represents an angle. So the angle in radians times 180 over pi will give you the conversion. And then to go from degrees to radians, you have your degree in degrees here. Sorry, your angle in degrees here times pi over 180. So I would probably write this down if you think you might forget. You know, we also could have used 360 divided by 2 pi and 2 pi over 360, because that's the conversion, right? It's 360 degrees and 2 pi and vice versa. But this is just reduced. Hopefully that clarifies it. So taking screenshots is really good for just having on your computer, but you really want to have handwritten notes, especially when we do identities coming up. I think in Unit 4 we do those. But you want to have like conversions, just like a piece of paper with conversion formulas or any type of formula we do. It's nice to have everything in one spot versus trying to click through different files on your computer. That's really not how notes should be. All right, so everyone, let's go ahead and convert these radians into degrees. All right, go ahead and do number 1. And what do we multiply by? Yep, so for number 1, what do I multiply that fraction by? By the way, what's written down, that is theta. So number 1, theta would be negative 35 pi over 6. That is theta. That's the given value. So multiplying that by 180 divided by pi. Yep. Let's see if it lets me write on it today. Not very good. All right, so, well, pies and pies cancel out. So what is negative 35 over 6 times 180? Negative 1050 degrees. Is there a 6 of 18? No, there is no decimal. Can't do a degree symbol. Oh my gosh, I can't use my mouse and do a degree symbol. All right, that's should be just a little degree symbol. Just erase it and do it again. Yeah, it's a simple conversion. Theta is the given. Theta is the given. So I'm giving you the radians, and you're multiplying that by 180 over pi. If it helps having this in front of the 180 over pi, go for it. Maybe I should have wrote it like that. I think I might fix my lesson and make it for that for next year. Yeah, you're just taking the given, this is theta, times by the conversion, which is 180 over pi. That's 180 degrees for pi radians. All right. Yeah, it's exactly what it is. It's a proportion. Everyone do 2, 3, and 4. I'm gonna give you guys. I think you can do it all of it in 2 minutes, right? Or do you want 3? 3 minutes. Okay, we'll do 3 minutes. My timer. 3 minutes. Got about a minute and 20 seconds left. Are the numbers always nice looking? Well, nope, not always. They could be decimal. Now the thing with decimals, you want to keep your, even if it is a decimal, I do want it in decimal format, but I think for these, they're all going to come out nice. All right. So I saw Julia wanted to do one. So Julia, do number 2. Who wants number 3? Antonio, number 3. Katie, number 4. Don't worry, there'll be more on the next page or two. All right, number 2. I think still writing the answer. All right. Okay, 80 degrees for number 2. Number 3 is 225 degrees. Number 4 is 120 degrees. Everyone agree with those? All right. All right. So far, Unit 2 is pretty easy. Don't get used to it. All right, now we're going the other direction. So now I'm giving you degrees and we want to go to radians. So we multiply by what? Pi over 180. Yep. All right, I'll give you 3 minutes for these 4. 3 minutes. Ready to go. And for these, I do want reduced fraction form. Yes, Inika, I'll let you do number 1. Maybe. Got about 2 minutes left. So hopefully your calculator gives you answers with pi in the answer. If it doesn't, you need to use a calculator that does or do everything by hand. So my FX 115 ES that costs, was it like $12? It does. The $10 FX 300 also does it. I think Desmos or GeoGebra, they do it too. All right, number one, volunteer. All right, Danica, number one. Number two. Actually, this is, I should say, number five. Danica, number six. All right, Caitlin, number six. How about number seven? Sarah, number seven. Number eight. Chloe, number eight. So remember, we are converting from degrees to radians. So we should be multiplying by pi over 180. So if you think about it, this is a basically a conversion. If we want to cancel out degrees that's in the numerator, we have to have degrees in the denominator. Because degrees and degrees, that symbol would cancel out, and you're left with pi in the numerator. So we achieved our goal of converting it into radians. Hopefully that helps. Number five looks right. That's a really nice pi symbol. Yeah, Nero doesn't like me either. What does this say right here? Ninety-one pi over 36. Okay. 5 pi over 6 here. And we got negative pi. All right. Everyone agree with all of these answers. We got pi over 12, 91 pi over 36, 5 pi over 6, and negative pi. Everyone's in agreement? All right. All right. I don't know. I don't have the answers. I expect you guys to do it for me. So if you all agree, I'll agree with you. So thank you. Okay, so conversion, degrees to radians, radians to degrees. It's good. All right. Okay, now the next conversion we're going to do. So there's something new called degrees, minutes, seconds. So you may have seen a key on some calculators that have a DMS button. That's what that is. I've never used it personally, but that's what it is. It's to convert from it's to convert from degrees to degrees, minutes, seconds. All right. The formula to convert from degrees, minutes, seconds is going to be degrees, the degree portion, the whole number, plus the minutes divided by 60, plus the seconds divided by 3600. This is the conversion, again, to go from DMS to degree decimal. I said that right. So it's just it's a different way to represent a degree. So all we've done in the past was degree decimals. That's what that's called. We can represent that degree decimal into DMS format. Okay, so don't think of DMS as being time, being a clock. It's not talking about how many like hours or seconds. It's not talking about that per se. So don't think of it as being time. So don't try to look at a clock face and say, oh, if this degrees is going to be equal to this time on the clock. It's not how that works. It's not the same thing. Okay, so first example here, we want to convert DMS into degree decimal. So this is 25 degrees, 53 minutes, 24 seconds. We want to convert this to degree decimals. So we are going to have the 25, the whole number, plus the minutes divided by 60, plus the seconds divided by 3600. So everyone type that in. Now I want the answer in decimal format, by the way. Hence the name degree decimal. All right, go ahead and type that answer in chat, please. Got a lot of 25.89s. Let's see if that is correct. Yeah, so that's 25.89 degrees. And that's it. It's really that easy. There's no other tricks to this. That's how you do it. Was everyone able to get 25.89? All right, so that's to convert from DMS to degrees decimal. All right, everyone try number 10. I'll give you all 30 seconds to do it because that's really all you should need for this. 30 seconds. And in 30 seconds, I'll have all of you write the answer in chat. So warm apple juice, don't they call that hot apple cider? I think that's pretty good. All right, time is up. I see a lot of answers. 67.19. That's probably right. All right. Yeah, that's what I got too. Yeah, so nice one, everyone. 67 plus 11 over 60 plus 24 over 3,600. It's really that easy. Any questions on DMS to degree decimal? All right. Got 2 more slides left. All right, now we go the other direction. So this one is not as well. It's pretty straightforward, but maybe not as fast. I guess I don't know. All right, so we want to convert 43.83 degrees into DMS, degrees, minutes, seconds. So we are going to take the whole number out of that. Well, that's 43. So, hey, that's going to be the whole number in the final answer. Look at that, 43 degrees. Everyone do good so far? So, yeah, this first lesson is super easy. Doesn't get hard until next week. All right, next, you're going to multiply the decimal portion. So we subtract 43 out of that 43.83. We're left with 0.83. Multiply that by 60. So everyone type that in. 0.83 times 60, hit enter. What do we get? 49.8. Yep, 49.8. So we take the whole number portion, add that, and that is the minute piece. So that's 49 minutes. So I break that my final answer, 49 minutes. By the way, the little single slash is minutes, the double slash is seconds. If you didn't catch that on or catch on to that. Yeah, don't round. We don't want to round anything, okay? So next, you take the decimal portion from that and multiply it by 60. So my question to you is, why are we not multiplying by 3,600 this time? Which is what Antonio did, obviously. Because we already have the minutes. We already multiplied the number once by 60. So multiplying it again by 60. Remember, 60 times 60 is 3,600 if you didn't know. So we multiply it once by 60 already. That gives us the minutes portion. We take the decimal piece out of that, multiply by 60 again to give us the second portion. So 0.8 times 60 is 48. And if we want to double check our work, we can go backwards. We can do 48 plus sorry, 43 plus 49 over 60 plus 48 over 3600. Hit enter, and we will, in fact, get back to the original problem, 43.83. It's a good way to check. Yeah, bug brains is actually a real thing. I think it's mad cow disease. It's when bacteria gets into your brain and eats it. It's a real thing, and as far as I know, there is no cure for it. So if you happen to get that, you are a goner. All right. Any questions on these steps? All right. Let's try one or two by ourselves. All right, everyone. Number 1 and number 2. Or sorry, number 1, number 11, number 12. I will give all of you. Let's do. How much time we have left? Oh, we have plenty of time. Let's do. Let's just do. Let's do the first one, and I'll give you all 2 minutes for number 11. Actually, I'll do a minute and a half. Let's see. Where's the delete? Oops. Let's do a minute. Do a minute and a half. Here we go. All right, minute and a half for number 11. Ready to go. So I'm not trying to trick you on number 11.
What do we do with no decimal?
Well, if
Put
no,
zero.
then is there seconds? How many seconds? Thinking. Mm-hmm. I still have a placeholder. You have about 10 seconds left. All right, time is up. All right, in chat, write the proper notation. I want to see the proper notation like you would write on a test or a quiz. All right. All right. Nice job, everyone. Yeah, so with 82 degrees, 9 minutes, 0 seconds. 0.15 times 60 is 9. There's no decimal portion. So there's no decimal portion. That tells us there's 0 seconds. Alt 248. Alt 248. Hey, that works. Alt 248. Nice job. All right, number 12. This is the last example we have, so let's go ahead and do, I think, a minute and a half for this one should also be more than enough. All right, minute and a half. Let's go. Uh, yeah, if you want to scroll and chat, you got to use your mouse wheel or the two fingers sliding up and down on the trackpad. Yeah, or arrows up and down. That works. You're right. All right, time's up. Everyone in chat, go ahead and write the answer. A lot of you are ready. Looks like we got 10 degrees, 57 minutes, 36 seconds. Got a lot of those. Let's see if that's right. That's probably right. 10 degrees, 7 minutes, 36 seconds. Yeah, nice job. And then there's the work to go with it. All right, pretty simple stuff. Any questions on today's lesson? All right, guys, this unit will get increasingly more difficult with new concepts. I'd recommend maybe pre-reading some of the Learn modules, at least maybe a day ahead before class, kind of go through it. I think it would really help. I agree. All right, so we have no questions, so I will end at that. And as always, guys, I hope you learned something.